Hocus Pocus.
Everybody focus.
Today is Science Quiz Day. We're wrapping up our magnetism. So for our performance task, we are, since we don't have enough ring magnets and I can't find the ones that aren't broken, we're going to draw and think about how we would have to set up ring magnets on a pencil to recreate that levitating magnet trick that the magician did in the very beginning. So please pull out your workbooks.
I think there's magnets out there.
And you need to flip to page 83. What page is it? 83. I'll wait. I'm going to give you a couple quiet seconds to get turned that page. This is not time that you guys are tough. You're just quickly, quietly following those directions.
Our next unit is weather changes or weather climate. Is it 83?
Darn, I was hoping there was one in the textbook too. It's page 83.
83.
And on this page is asking us to think back to that magician trick where there was a pencil and there were magnets that were levitating on that pencil. And I'm going to project that picture here just to remind you. Okay?
Oh
Let me
yeah.
get it pulled up.
Those little ring
Right
magnets.
now, I don't want you to hear the sidebars. We're just going to look at it together.
Is your projector open?
All right. Here is that picture that they're talking about. So this is a magician's trick where he made these magnets levitate. Think about what we've learned about magnetism to figure out how did he do this? Because we know is magic real?
No.
No, he was using science and he was using magnetism for this trick to happen. So look at it first. And this is actually on your workbook. It says, ask a question. What will you need to consider as you recreate the trick? You're going to cross that part out because we're not actually redoing it. So in your workbook, the top line part, you're actually crossing out. 5, 4, 3, 2, 1, and 0. And then we're moving on to numero uno. Look at the photo of the levitation trick. Here it is. Write the steps that it will take to recreate the trick. So who can label some of these things for me? And you'll just raise your hand and tell me, and I'm going to add it to my picture. I will start with this because I think it's hard to tell from the picture, but this right here, this is just some clay that they stuck the pencil into.
I know how.
It's just a base to hold it.
Yeah, me too.
I better use darker marker so my online friends can see. Hocus Pocus.
Focus.
Please make sure that you're not flirting. My friends that use GTA are going to be the ones who share for this. So here's our clay. What else are we going to need for this magic trick to work? Keegan. Yes, so we have these 3 ring magnets. Unfortunately, we don't have enough of them here, right? But that's what we would need to recreate this.
No, we can't. Yeah.
Nope.
Yeah, you can.
Nope, we would need 3.
We don't.
And I'm actually going to put that. We would need 3. We would, and we'll talk about, I think my mic stopped again. It did. We'll talk about why we need 3, but what else?
I know why.
What else are we going to need for this to work? Brielle. Ooh, what parts of my pencil need to be magnetic? When we tested our pencil in our experiment, was the pencil magnetic?
No, but
So the pencil must be used for something else. Can anybody think of why we need this pencil? And I'm looking for that GTA. Why is a pencil used? And could it be replaced with anything else? Savannah? There is lead. Actually, the pencil that you guys use is graphite. It's not magnetic. So it doesn't have anything to do with magnetism. It does have to do with the fact that these are ring magnets. So why are we using that pencil, Skylar?
Because our pencil is like a circle.
Absolutely. Our pencil's kind of like, you remember talking about wheel and axles?
Yeah.
It's almost like your pencil's the axle that the ring magnets can slide
And
up
I
and
know
down
why.
on, so
I
that they
know
can
how it
still
works.
move up and down, and it keeps them from tipping over, right? So this is really just used to stick into the clay and hold everything in one spot. It has nothing to do with magnetism, but is it important how we line these up?
Yes.
So I want you to
It's
think
because it
for a
goes
minute.
north, south, south.
I want you to think for a minute. How would we need to line up our magnets so that they would look like they're levitating? Think for a minute because I'm going to have you share with neighbors first. So don't talk yet. Right now you're thinking, and really think. What do you know about magnets that would make them push or pull away from each other?
North,
Addison,
south.
third grader, sit up.
It's north and south.
Ready to talk with your neighbors? Teach.
It goes north, south, and south. Because north and north are negative. We're done.
Online friends, this is going to be a question prompt on your slide. So really think, what would we have to do when we're lining up our magnets to make them push or pull away from each other? What do we know about the poles on these? Okay?
I think the reason they put like that is because north to north on one side and then south to south. Yeah, north on one side and then south on south and one other. Yeah.
All right, my friends, who thinks that you figured it out with your partner? What are some things that we're going to do? I'm going to need my marker to label your thinking here. Riley, what'd you talk about?
I think that they're all negative. So the bottom one's negative. So the bottom one pushes the top negative magnet, and then that negative magnet in the middle pushes up the very top magnet.
Maybe. I think I need to remind you guys something because I think I only shared this once. But on a ring magnet, it's kind of like 3D. And so it's like a donut. And so one flat side, like the top side, might be positive. And if the top side's positive, the bottom side is negative. Or we could flip it around and you can have it. I'm going to try to draw it so that you can actually see both sides. That doesn't really work. But if this side's negative, then the bottom side would be positive, right? So it's like a washer where one side is positive and the other side's negative. So it wouldn't be that the whole ring is, but your thinking is totally on the right track. Thinking's on the right track. Who can kind of build off of that? Addison.
So if the middle on the top is positive and the one on the top is positive at the bottom,
Like that?
then those will push away and then that one will flow, and if the top on the bottom one is negative, then it will push the middle one away.
Let me zoom this in for my online friends so that they can see better. But here's what Addison's saying. Is that, oh no, I'm blocking. There we go. Is that if I start with my middle washer or ring magnet and my positive charge is on the top side, then the bottom side of the top ring magnet has to be positive so that they're pushing away from each other. And the top side of the bottom magnet would have to be negative to push away from the negative charge on the bottom of the middle ring magnet. Now, think really quickly. That's because my middle magnet is positive on top and negative on the bottom. Is there any other way that I could organize these that this would still work? Because Addison's totally right. This would work. This would do it. Is there any other way that I could organize my magnets? Kevin?
It's south and south and north and north.
Oh, yeah. So instead of saying positive positive and negative. I lost my marker. Instead of saying positive and negative. Okay, so we just relabeled these. Our negative charges we were labeling as south and our positive as north. What else could I do? Instead of having them this direction, there's one other way that I could organize my magnets so that this would happen. What do you think, Skylar?
Just flip it around.
Yeah, I can flip it around. So let's say I flip this one so that it's actually north on top and south on the bottom. Then my middle one have to be
South, north.
south and then north, and my bottom one would have to be
North.
South.
north and then south. Friends, I would like you to flip to page 84 in your workbooks. What page do you need? Okay, go ahead and flip there. Five, 4, 3, 2, 1, and 0. Page 84 asks us to draw a model of that levitation trick. And so you're going to label the north and the south poles. Would you rather see the picture that we already did, or would you rather me draw it with you?
You draw it. Picture that we already draw. You
Stand
draw
up.
it.
Stand up if you would rather draw it with me. So we all can do it together. Stand up if you would rather look at a picture. We're about 50-50. Let's just draw it together because then this is kind of messy. So, pull out your pencil. Now, for us to start, first of all, what did they use as kind of our grounding item at the bottom to stick our pencil into?
Clay.
Clay. So go ahead and put a big old wad of clay at the bottom and label it clay. What next? What would be a smart thing to add next to my picture, Ellie?
Hey, we can do it like
That
this.
pencil, and you
Yeah.
can just show your pencil.
Can't we do this
Standing
and
up.
then put magnet rings around it? That's actually a good idea.
Yeah.
I don't think I can draw that.
Yeah, you can. It's just a rectangle with some stripes going through.
can draw a Lamborghini. You can throw some.
Oh, no.
Now to make our rings, we do need 3. The first one gets to balance right here. So go ahead, you can draw it like another rectangle this direction, but we're gonna shade it in. So it looks like a ring magnet. What side do we want facing up on our bottom ring magnet? Thumbs up for north, thumbs down for south. Most of you guys are saying north, so let's go ahead and label the top side of this as north.
Can we just write N?
Absolutely. Now we do need 2 more of these magnet rings, so we're going to draw 2 more rectangles. Make sure that we've got space in between each one, right? Because we want to show that they're levitating. Yeah. So now we've got 3 magnet rings that are kind of levitating there. And this is where I need the help of my scientist to help me label which sides of these would be north and which sides of these would be south. Rylan, which? Oh, go.
So the other side where you put north, you have to switch it to the other side and put south.
So you're saying right here?
No, like switch. So you know how you jump back and like when you jump like this.
Uh-huh.
This is south, and if you jump it up, it will land on south.
Good. Rylan, do we want this one to stick to that magnet or be pushed away?
Pushed away.
Pushed away. So if it's facing a north charge, what charge is going to make it push away? What? Would the opposite, south, make it push away, or would the same charge, north, make it push away?
Opposite.
Ooh, opposites attract.
No.
I mean, like,
So we want it to be the same one? So if this was north, this also has to be north. Very good, because we want like charges repel, and the opposites are the ones that are going to attract, okay? Which means if the bottom of this magnet is north, and I think this is what you were talking about, if the bottom is north, the top of it has to be south. So let's go ahead and label south on top.
So if that one's pushing it away, if the top one, the middle one, we're gonna squeeze and get pushed away.
Mm-hmm. Now my question, other question to you guys based on yesterday's experiment, about how much space do you suppose we're getting in between these magnets?
A
How much space did
centimeter.
we have in our magnetic field yesterday, Riley? Yeah, just a centimeter. So are these very far apart? No, unless we have really crazy strong magnets, these are going to be pretty close together, especially because they're so tiny.
And because
Hadley, if this one is south and I need to push that next magnet up, what would the bottom side of this next magnet be? To repel south. Very good. Gonna make sure that you put your water bottle down because it looks like you're playing with it. You bet. And if the bottom side is south, everybody, the top side would be well, guess what?
don't forget to label
I
the
think-
pencil.
Yeah, don't forget to label the
Touche.
pencil. Pencil.
Pencil or any other rod.
I'm just gonna say.
Can you use a balloon?
I think we're ready. Let me kind of preview for our quiz.
Look, you can, instead of clay, you can use an eraser.
You could.
Tomorrow.
Sorry, man. That's happened because you're
No,
a little.
tomorrow. That's today. Our spelling test is tomorrow. Our spelling test is tomorrow.
Okay. We are moving on to our science quiz. What is it?
Science quiz.
I want to preview it with
Our
you.
spelling
Actually,
test is tomorrow.
Miss Johnson, would you mind passing these out? And I'm going to read it for them as they go through. So as soon as you get this, you don't have to put your workbook away unless you want that space on your desk. So you decide. But as soon as you get this quiz, you need your name, number, date on top.
Name, number, date on top and stop.
Top and
Wait, no, it's name, number, date on top and stop.
Should you be talking about it as it comes around to you?
Yes.
No.
do you want us to wait?
Yes.
Today is October 27th.
October. I have a question about the strike. What if it's on like a Friday and you get it? Would it still end till Friday?
Go through the following Friday.
Like if it's the last day of the strike?
Hocus pocus.
Everybody focus.
It's still coming around to some of you, but I want you to start hearing these problems. So numero uno. True or false? A compass uses the magnetic field of the earth. Don't answer it.
Yeah.
Think about it. True or false? A compass uses the magnetic field of the earth. You may answer it on your page. Go ahead and put it's A for true,
Shows the
B for false. I just meant don't say it out loud. My bad.
You put on the line.
Yep. So if you think the answer is true, you would put A on the line. If you think the answer is false, you would put B on the line. Because the way that this test is written, it has a line for you to mark your answer. So we have to follow the testing format. Numero dos. Which would be attracted to a magnet? So as a scientist, I'm thinking in my brain, we know about magnetism. We know that a certain type of material attracts to magnets. And so you're listening for that type of material. And think about your first experiment. A plastic button, a rubber band, a paper clip, or a wooden toothpick. Only one of those items was attracted to the magnet in our first experiment. So please mark that as your answer for number 2.
What's a wooden toothpick?
The button, just a regular toothpick. The button is A, the rubber band is B, a paper clip is C, and the toothpick is D. Okay, numero tres.
Numero tres.
Which pair of magnetic poles attracts one another? And this, ooh, we just did an experiment on this. Would two north poles, two like poles attract? Or two south poles, two like poles attract? Or one north and one south, which are opposites, attract? Or a neutral, which means that there's no charge, and a south? Think about what attracts. Do the same charges attract or do opposites attract?
These are easy.
Both A and B are the same charges. C is an opposite, and D is one with no charge and one with a
What
charge.
does it say? Which
Skylar.
part?
Should I hear any voices for a quiz? Check those.
There's a backside.
Numero cuatro. This is on the back. This table is actually showing a bunch of materials that Gina collected. So it says, Gina collected data on what materials a magnet attracts, just like we did. We did an experiment like this, right? So Gina collected a metal cup, a plastic cup, a wooden block, an iron nail, a rubber band, and a plastic bag. And then she went with her magnet and she saw, did it attract to the magnet or did it not attract to the magnet? Two items look like they were attracted by the magnet. And I see that from my heading in this table. Many items, in fact 4 items, were not attracted by the magnet. The question is, which conclusion can you make from the data below? A, magnets attract some objects made of plastic. Well, there's a plastic cup and there's a plastic bag, so you would look, were those attracted by the magnet?
Well, one was.
The plastic bag was not, the plastic cup was not. B, magnets attract some objects made of metal. Well, there's a metal cup, that was attracted. And there's an iron nail, iron is metal. C, magnets attract some objects made of rubber. The only rubber thing I see is a rubber band. Okay. And D, magnets do not attract objects made of glass.
That's true.
Do we see anything made of glass in our data?
No.
Okay, so only one of those statements can be proved from this data collected. You need to mark the one that can be proved from the table above. And then we have 2 written responses. Numero 5.
Numero cinco.
Describe how the distance that an object is from a magnet affects the magnetic force on that object. There's a couple words that I want you to use in this writing. Are you ready?
Yes.
One word that I would like to see in your answer is magnetic field. That's a vocabulary word I want to see in your answer. Another word that I should see in your answer is magnetic force.
What? You have all of them?
And I want to see the word stronger or weaker. You got to choose.
What? Is all those?
Because we talked about this with our ruler experiment. How does the distance that an object is from a magnet? Remember when I put that ruler down and I laid down my paper clip and I put the magnet far away from it and I put it closer and closer and closer. How does that magnetic field and distance affect the strength of my magnetic force? I'm going to give you a moment to answer that question.
This is, yeah, we need like 10 minutes. Yeah.
By using those words, you can get all of your points. If you give me kind of a weaker answer, then you wouldn't get all of your points. The last one, how can you use a magnet? We would restate the question a little bit. You can use a magnet to, and you would finish that sentence. Tell me something that you can use a magnet to do. We've done some things in experiments. You've done things at home with magnets. You can tell me about any of them.
Connect things. Maybe.
So don't just tell me you can use a magnet to connect things. You would need to be specific. How does your magnet connect things, okay? And that's all you have, online friends. Good luck, my friends in here. I'm going to give you still 5 more minutes. And if you need more time to answer those 2, you may. Otherwise, when you're finished, this is going to go in box 2. Where does it go?
Box 2.
All right, good luck.